Hi everyone. We will be discussing the tree and graph structured data. The structured data is a way of organizing and representing information in a well-defined and logical manner. It plays a crucial role in computer graphics by enabling efficient storage, manipulation, and rendering of complex graphical data. Trees and graphs are fundamental data structures that provide a structured way to represent and process graphical information. So now, first of all, what is a tree? A tree is a hierarchical data structure consisting of nodes connected by edges. It has a root node, the internal nodes with children, and leaf nodes. So basically, this will be the root node, and this would be the internal nodes. And this end nodes are the leaf nodes. Now, the properties of trees are that every node has a unique parent except the root, and the structure is acyclic. That means there are no cycles. So in the previous image as well, we saw that there was a root element and there were two childs of the root elements. And for every child, the parent is unique. Okay. There are various types of trees like binary tree. That means each node has at most two children. N-array trees, that means each node can have n children. Balanced trees, in which the height is minimized for efficient operations. And applications in computer graphics is that for scene graphs, that is the hierarchical representation of 3D scenes, and bounding volume hierarchies, that's for spatial partitioning, for efficient collision detection and rendering. Quad trees, octrees, spatial decomposition for level of detail rendering and terrain data. In binary tree, the binary tree is a tree where each node has at most two children, left and right. So these are so this is left and this is right. Traversal algorithms are the pre-order, in-order, and post-order. In pre-order, firstly we visit root, then left, and then right. In an order, we firstly visit left, root, and then right, and post-order we visit left, right, and then root. The example is the binary space partitioning. Trees divide 3D space into convex regions for efficient rendering and visibility determination. What is a graph? A graph is a non-linear data structure consisting of vertices and edges. So these are the nodes or the vertices, and these lines are the edges. The properties are that the vertices can represent objects or entities, and edges can represent relationships or connections. Graphs can be directed or undirected. It means edges can have direction, or uh, edges may be bidirectional. So graph can be directed or undirected. So the representation is like adjacency matrix and adjacency list. So types are weighted and unweighted, planar, etc. Weighted, that means there will be a weight attached to each edge. In unweighted, there will be no edge attached to the edges. Okay. And graph traversal, depth first search, explore as far as possible along each branch before backtracking, and the breadth first search, visit all vertices at the current depth before moving to the next level. Applications in computer graphics is pathfinding, finding shortest path in game environments for navigation, and then visibility determination, computing visible portions of a scene from a given viewpoint. Then mesh representations. The polygon meshes are commonly used to represent 3D objects in computer graphics. Meshes can be represented as graphs with vertices, edges, and faces as data structures. Winged edge and half-edge data structures provide efficient storage and traversal of mesh connectivity. Then come to computational geometry. Computational geometry deals with algorithms and data structures for geometric problems. Voronoi diagrams partition a plane into regions based on distance to a set of discrete points. Gilliansky triangulations and dual structures of Voronoi diagrams forming triangular meshes. Applications in computer graphics is terrain rendering and object modeling. Then hierarchical data structures. Bounding volume hierarchies are tree-like structures that recursively partition 3D space into bounding volumes. Octrees and quadtrees are spatial partitioning data structures that recursively subdivide 3D or 2D space into octants or quadrants. Applications are ray tracing and collision detection. Performance consideration is trade-offs between memory usage and computational complexity. Optimizations are spatial data structures for efficient culling and level of detail techniques for large datasets, and parallel algorithm divide and conquer approaches, data parallel techniques for processing large-scale data. That's all. Thank you.